Hello, everybody, and those online too. Hello to you. So, Docker Toolbox. If I, no, okay, you're using the playground. Okay, your system might not be able to carry it. And log in. You need to create an account if you don't have an account. Okay. Which version of Windows are you using? Just go to command prompt. Or you can log in too. Yeah, command prompt. Sorry, can you see? But it says that can you see the reason why? I think that the processor cannot. But let's start from top. Let's start from top. But I've checked it. Authorization is already. See, Windows 10 Pro. So let's work if you have the 10 Pro to work. So maybe it's the processor. Should be charging mine. Close down. Yeah, go to bang. Should be restart after installing. We have to finish. And it's enabled now. Okay, enable container. Scroll down. Okay, I pass it. Scroll down. Wait, so did you enable hypervisor platform? Windows hypervisor platform. Windows hypervisor platform. Okay, enable it now.
created the command for some of these Windows features. What command did you give him?
for
These Windows features.
okay, I just type Windows features.
And you brought it.
Yes. Now,
Yeah, restart. Okay. I hope it doesn't hang your system. Can send you.
if I was no work, however, I have
Wait, let me see. Okay, it's Windows 11 you're using. Okay, Windows 11. And it's working. I just typed it to see if it got in. Yeah.
but which command was that? Hmm? Command.
Open your command prompt. I'll be your tax manager. Tax manager. Want to check something. Okay, virtualization is enabled. Go to Windows features. Windows features.
Where?
Windows features. You can close your tax manager. Okay. Okay. After I finish, restart. Okay, welcome back, everyone. Please let's focus. Okay, welcome back, everyone. Hope you had a nice lunch. I hope you had. So I think everyone has it installed. Okay. desktop is not working. Some Docker still work. So it's the next one after the Docker desktop link. Okay. Okay, I think about 90% of us have it installed. Thank you for that. So we'll be moving to the commands, some commands that you can run. But before I go on, let me just ask simple questions to see if people got what I said this morning. Who can tell me what a container is? A software container. Okay, let me start with image. Who can tell me what a Docker image is? If you get it, there might be something for you. Who can tell me what a Docker image is? Okay, thank you. Thank you very much. Templates for creating Docker container. Very simple. And who can tell me what a container is? Runnable instance of an image. Okay. Thank you. Yeah, exactly. Just like class and object. So, um, so these are these are commands for managing containers. So the first command you can run is docker-help. So this can be used. This is a very, very useful command. So in case you come across any command that you don't know or you have no idea about, you can run docker command-help and to show you the way you can run the command. This is very useful for us as beginners. Even me, I still use it. Let's say I have a command and I don't know how to use it. I just use docker command-help. So the first command I want you to learn is docker pull image. So as you said, an image is a template for creating a container, and the container is a runnable instance of that image. So we need that image to run a container. And the first command we can use to run the image is docker pull image. And as I said, in the Docker architecture, there's a Docker registry where all these images are stored. So these images are stored in the Docker registry. So when you use the docker pull image, it goes to the registry and it pulls this image for you and stores it on your computer. So the Docker registry is hub.docker.com. There are different registries, but the common one is hub.docker.com. It's a site. You can also visit it, hub.docker.com. Actually, we will still go there later to create accounts for ourselves. So this is the first command to pull an image from the registry to your system, docker pull image. We will be using it in the practical. You don't need to try it out now. This is just slide. This is just theory. We have a practical file in the course practicals that you downloaded this morning. So we will try this. So the next one is docker run image. So now I want to convert the image into a container. To do that, you can run docker run image. So you can see here, if it doesn't locate the image on your system, it will pull it for you and it will start the container for you. So the docker run is used for converting an image into a container. So it's very simple. First one, docker pull image, to get the image from the repository, from the registry, not repository, it's the same thing, repository registry, to get it from the registry. And the docker run is for converting the image into a container. I hope the people online are following too. If you have questions, you can pull me back. So there are different ways of creating an image. Normally, when you create an image, different ways of creating a container. When you create a container, it will print the information about creating the container on your terminal. But if you want to avoid that, you can add the -d, meaning run in background. You can add this -d, so meaning run the container in the background. Don't print out all the information for me. So you don't need to try it yet. This is just theory. We'll get to the practical soon. So there are different ways of creating the container. So here we are running docker run -name. So if you want to give the container a name, because it's creating a container, if you want to give it a name, Then we'll use the -name information, -name parameter or argument, and we'll pass in our name, chosen name. I wish this thing had the pointer. Yeah. Bro, sorry. Does the pointer work? The pointer. It's not showing on it. It's showing on the wall, but it's not showing. Okay, it's showing. I think the battery is weak. Maybe it's the battery. So let's continue, please. So if I want to give the container a name, I just pass this -hyphen name. Please let's pay attention. And the chosen name. Then this is if I want to remove the image after I stop the container, I can use this -rm. So these are arguments we can pass to the docker run command, and we must always specify the image. Anytime we want to create a container or run an image, you must specify the image. So -name gives the container a name. -rm removes the container after stopping it, because if you just stop it, the container will remain on your system. So you want to remove the container because they're actual systems, and if they are too much, it will eat up your hard drive. Okay.
There are some comments you've made. I mean, like when you have create plus start, container in the background. I think that's the comment.
Yes.
Because it's kind of mixing up with the other commands and the flags you're issuing. Is there any other way to distinguish the comments from the flags and the commands?
Okay, you mean this?
For instance, now from here is and it's a comment.
Okay. Oh, okay.
It's a comment too.
Is a
So
comment with
it's kind of
like combine them?
yes.
Okay, okay. Sorry about that.
Maybe hash or something.
Okay, sorry about that. So this is a full command, docker -help. Docker command, any command like pull. If I want to get information about it, I can use docker pull -help. So it will give me all the information about docker pull. So you can, that is for getting help information. It's very, very useful. Even I still use it. So in case you see a command that you don't know about and you want to learn, you can just use docker, name of the command. I can use docker run -help, and to show me all the information about docker run. So docker pull image. So this is the command. This hyphen is just giving us comments about this docker pull image. So docker pull image. So you want to create a container from an image, but you don't have that image. You can create your own image, but we've not gotten there yet. But if you want to use existing image, you have to pull it from a repository to your system. You know, I talked about in the Docker architecture, I talked about having a repository. So all the Docker images are stored in the repository. So if you want to have it on your system, the command to use is docker pull image. So you to pull it from the repository, and the name of the repository is Docker Hub. So you to pull from Docker Hub to your system. Then if you want to create a container, you use docker run image and some additional commands that you want to run. So this will pull the image if you don't have it on your system, and to start the container for you. Then docker run -d. So these are arguments you can pass to the docker run command. So this will create and start the container, but it will start it in the background. Normally, when you start a container, it will print out log information about that container. It will print out some log information. So if you don't want to see those log information, just use -d. It will just run the command in the background for you and to start. So some additional commands you can pass the Docker run is -" name. You might want to give your container a name, a special name, so that maybe when you're running subsequent commands, because you can run subsequent commands on your container. When you're running subsequent commands, you just use that name. So you use -" name and to give you the chosen name. So if you want to remove the container after stopping it, so maybe when you stop it, you don't want it to be on your system, because if it's still on your system, it will be eating your hard drive, because it takes some space on your hard drive. So if you want to remove it immediately after running, you use -rm. So this is the comment: create plus start container with the chosen name. Use -rm to remove the container after stopping it. So that is the comment. So Docker run -it, then this is the name of the container. This is just an example and a command. So this means create container for the IPAN image. IPAN image is a flavor of Ubuntu, but it has been stripped down. So a lot of things that are in Ubuntu have been removed from this IPAN image to make it very lightweight, because that's one of the advantages of containers. They are very lightweight. So you should strip down some things. So this IPAN is a flavor of Ubuntu image. So the Ubuntu image and the command you want to run. So this is -it. It means create an interactive shell. Normally, when you run your command, your Docker run command, it will stop immediately. Immediately you run it, it will show some log information and stop immediately. We will still try it. So, but if you want to create a terminal from it, then use the -it for it. It will start a shell command for you. So we will try all these things out in the practical section. This is still the theoretical section. So there are more commands. Docker start container. So this is another way of starting a container if you don't want to use the Docker run. So, but first you have to pull the image in this one. This one, if you don't pull the image, it will result in an error. But you can type Docker start container. Docker start -a container means output the log information. So there are some log information that will come out by the time you start the container. So you use the -a to get those log information. So if you are done with the container, you can use Docker stop container. Maybe open another terminal and use Docker stop to stop the container from running. Because let's say you're running a database now and it's running in the background, so you have no way to kill it. If you want to stop it, you can just open another terminal and put Docker stop container. So these are all commands that you can use with your Docker terminal. So Docker kill container, this one will completely stop it. The first one will stop it gracefully, meaning it will allow the container peacefully release all the memory and resources it is using. But Docker kill will just abruptly kill it. It will just stop it at once for you. So that is an hash container, hash command. Docker restart container means stop and restart it. Maybe you just want to restart it. Stop and restart it. Docker pause will suspend it. And Docker rm-help will remove and destroy the container. So sorry about the way I presented this slide. In the next one, I will try to keep it cleaner. So all these hyphen are just comments. Where you see this hyphen is a comment to the command. So this, I should have made it a different color. Sorry about that. So these are the commands and this is the comment. So in case you are reading it later, this is the command. Then when you say hyphen, this is the comment to it. No. It's the name of your container. Yeah. Yes. Docker stop CU. Docker start CU. Yes.
How about you have Docker run -- name? What is the name of the container?
And yes, you are giving the container a name. So normally, Docker will give you a default name. We will see it. Docker will give you a default name. it will give a very default name. But if you want to choose your own name for the container, then you can use hyphen name. So you now take it, the Docker, let's say you've run it and it has stopped. You can now use Docker start container to start it again.
Okay, so let's assume that my username is username.
Yeah.
This one, so I can now say Docker start username.
Yes. Yes. So let's say you run it and you stop it, or maybe it stops because containers can fail, and you want to start it again. So you use Docker start container. So let's say it's running, because this, you can see, it will pull the image and start it. It will do this Docker start for you. But let's say it stops. You are running it and you want to stop it. So you just put Docker stop container, the name you gave to your container, or the chosen name you gave to your container. So if you want to see all commands, all containers that are running on your system, if you want to see all containers, you use CApIC-ACE. So it will list all the containers that are running on your system. So when you list it, it will show a table. It will show a table with all the information about the containers. We will still try this very, very soon, shortly, because I notice it's not good just theoretically discussing commands. So trying it out is the best, but we'll try it in the practicals. The practical is the next section. So please get ready. So this CApIC-ACE will list all running containers. It will show the container name, it will show the image name, it will show any ports that you have given to it. It will show everything. So CApIC-ACE. So CApIC-ACE will show all running containers plus stopped. So in case you have stopped a container, in case you stopped it, it will show all running and stopped containers. So if you have images on your system and you want to list the images, you can use Docker images. So this will list all images on your system. So when you have pulled several images on your system, just put on Docker images and to list all the images on your system. So Docker logs -f will show the container output information. So if you want to see the logs of the container, it will show this command to show Docker logs -f and the container name. There should be an hyphen here. Sorry. Yeah, after sure. I think I did this. I don't know why. Maybe I'm sending an old slide because I know I updated this thing yesterday night. So Docker top container. So in your Linux system, you can do top to view all the running processes. If you want to view all the running processes on your system, on your Linux computer, I know we know about that command. I think we did Linux recently. So top will show all the running processes. So if you want to do that in a container, you can do Docker top, then the name of the container, and to list all the processes running in the container. So sorry, there should be an hash here too. Hyphen. Yeah, sorry. So Docker inspect container will show low-level information about the container. If you want to see some additional information about the container, you can use Docker inspect container. So you can do the same thing for the image. So if I want to execute a command in the container, let's say I have a command I want to execute in the container, I can do Docker exec-it, the container ID, and the command. So you can see an example here. So Docker exec-it, then this is the name of the container, and this is the command I am running. Name of the container. So there are two names, so we will get there too. There are two names of a container. There's the container ID and there's the container name. So this number you are seeing here is the container ID. I can also use the container name. So the container ID is one long string. We will also see that in the practical section. And then the command. So if I want to remove an image, because this image is also eat up your space on your hard drive, space on your system, if you want to remove them, like as I said, Alpine is a stripped down version of Ubuntu. So Alpine is very small, but if you pull the Ubuntu image, it's quite large. We'll see some example, it's quite large. So If you want to free space on your system, you can use Docker remove and the image ID. So to clear all stopped containers, you can use Docker prune, Docker container prune. We clear all stopped containers so you can free space on your system. And to delete all images, you can use this command. Okay, Docker system prune will remove all dangling and stopped images, volumes and containers and networks from your system. Okay, yeah, so practicals. Let me open my system. So in the file we downloaded, in the GitHub file we downloaded, we will see a file there. Let me open my browser. So in the file we downloaded, we see a text file there. This is an example practical section we can go through right now. So do you want me to run it on my system, or I should just call the command and I check it on your systems? Because I want you guys to run it too, not just me running it and you guys just watching. Please, let's contribute. Okay. So as I was saying, so I hope my course is not too boring. If it's boring, let's spice it up. As I was saying, do you want me to run these commands on my system and you guys watch, or you want to run them on your system too, or we run it together? Run it together. So let me open my terminal. Yeah, is it big enough? Okay. So can you see the text file on the right hand side? So is it clear enough? It's on the GitHub repository, so you can also open it on your system. And it's on the first link I showed this morning. Okay, and this is just the terminal, your command prompt.
What do you? Yeah. I did something. Okay, that was terminal. CMD terminal. PowerShell now. I just search for it.
So the first command I want us to run is docker-v, and it's to check if Docker is installed on your system. So I just wanted everyone to be on the same page. Docker-v. So run that. So you can see that Docker is installed on my system, and that's the Docker version 20.10.8. Yeah, so you people have a more recent version. It's the same version 20. I've installed my own for a long time. So this is the file.
This one. Just. How do I open my terminal now? Okay, is this one?
Since you have Docker installed, you can type the commands. So if this command gives you an error, please raise your hand. It means you don't have Docker installed. Error. Any issue? Okay, thank God. People online, if you have issues, please try to get across to us. Yeah. Okay, raise your hand if you have an issue. Okay, no, this is just a text file. So the hash is like a text. Yeah, so you just copy the ones that are without the hash. Only the command, yeah. Yeah, yes. I've installed this one for a long time. With stress. So no one has issue with this command. So the next one is docker info. So this will get information about Docker and your system. So information about Docker and your system. Let's try it out. It's not clear because let me minimize. So you can see it's printing that information about the Docker system on my Docker system installed on my laptop. You can see, if you recall, I said Docker uses a client server architecture. So this is the client. It's telling me about the client here, the client, and the server. So it's telling me the containers that are running on my system. The ones that are running, the post ones, the stopped ones, the number of images on my system. You can see a lot of images. It's in my hard drive right now. But I'll clear them very soon. I just have some important images and some other information. And because you are just starting, no problem. So it runs successfully. Please, does anyone have issue with that command? And it's just some low level. You don't need to. Yeah, me too. I have that error. That warning, but Docker will keep on running without issues. So now we want to pull an image. Please pay attention. I can ask questions at any time, or I'll call you here to come and help me out. So the next command we want is to pull an image from the repository. You know, when I was talking about the client server, the architecture, there is a client, there is a server, and there's a repository. So now we want to pull an image from the repository. And Docker is not running. It's not running. It's not running correctly. The client is running, but the server is not running. So maybe restart Docker or restart your system, but you can just restart Docker. It's supposed to show you. And don't worry about that same error. Try to restart Docker. Still starting. That's right. Yeah, it's okay. It's okay. Normally you can set it to boot with your system. Normally that's the way it does. But okay, thank you very much. So as I was saying, we need images on our system to create containers, to create the containers. So we don't have the images on our system. So what we do is to go to the repository. So let me even go to the repository so that you can see. So that you can see the repository. So the repository is hub.docker.com. 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 So this is the repository for Docker images. So I can search for any Docker image I want here. Ubuntu. Ubuntu is the image we want to use next. So we can see information about the Ubuntu Docker image. So this is the Docker official image. Because people can also push their own Ubuntu images to this site. You guys, so by the time we get to the practical section later, I think the second one, you'll be building your own image and you'll be pushing to Docker. So you can see the number of times it's downloaded, so you know that this is the original Ubuntu image. So you can just read some information about it if you want. What is Ubuntu? What's in the image? How this and that is done. Let's go to another one I talked about, Alpine. So Alpine is the stripped down version of Ubuntu. So this one has the full Ubuntu resources or the full Ubuntu configuration. This one has it, but a stripped down version, which is lighter than this. A stripped down version is the Alpine image. Let me go to it. Alpine. So this is the Alpine image. So you can see a minimal Docker image, a minimal. So it's much more smaller than the Ubuntu image. A minimal Docker image based on the Alpine Linux. So it is based on Linux, but some commands have been removed that makes Ubuntu big, has been extracted from it, so that you can just use what you want. For, you are trying to build applications with this thing. So if you are using a fat base image, your application will be big also. You also want to share it. You also want to share it from maybe from your local system to a server. So if you are using a big base image, you might be sharing a very big image with your server, and it might take time to upload. So you have to take care of that. That's why we use the Alpine image. So let's go back to the commands. No, you don't need to register. Well, we will still register on this site later, but you should be able to view it. So now we want to pull the image from the repository, from the registry to our system. So that is what this next command is. You know, I said in the theoretical part that this pulls the image from the repository to our system so we can create a container from it. So let's run this command now. Docker pull Ubuntu. So this might not take time for me because I have it, but for you it will take time. Let's run this command, docker pull Ubuntu. So this will pull the Docker image from the repository into your system. So we can create a container from it.
I have to do this before I put. Oh, okay. So, but it's not saying it. I'm connected. Okay. I became a full login. Okay. Ubuntu Docker image. Only can search Ubuntu Docker image. Abi? Should I? Yes. Yes, that's where. Yeah, what internet? Oh, one there. Okay, it has to do with Oh, that means the quota they gave here, we have exceeded it.
Okay. So let's put the Ubuntu image into our system. So Docker pull image. Okay, so mine will download it also. So you can see pulling library slash Ubuntu is downloading. You can see the size, 29.53, but I don't think that's everything. Okay, 29.53 MB. So I have it on my system now. Let me pull the Alpine image so that you see the size too. So you saw that the Ubuntu was 29. The Alpine will be much more smaller. Okay, already exists. So I already have the latest version. So I just wanted to put the Ubuntu image for us. So now that we have the image, we can now create a container from it. So that's the next command. But let's check the list of images we have on our system with Docker. That's the next command, Docker images. So for me, I have a lot of images. So you will see a lot of information. But for you, you shouldn't. And to pull from the online repository to your own local repository. So please, do you have questions? Questions? Are you enjoying the course?
He's not going back to where it's supposed to be. You see my command. What's the problem?
You are running this cat command. This cat command keep on receiving input from two press controls. Close it. Yeah. So you can now view the content of the file you want to press.
That's LSL, right?
The name of the file.
That's hack.
Test.get.
Okay, okay. Sure. Thanks.
And it went through.
Even that search, going back to that search,
It's now working.
is now working.
Okay, thanks for that. So I want to show you the images on my system. So I have a lot of images. A whole lot. But for you should just see one or two. So you can see the repository ID of the image, the time it was created, the size, and the tag of the image, and the name of the image. You can see, sorry that my own is like this because I have a lot of images. So for you, you will please type it so that I can see it on your system. Docker images, it will list all the images on your system. So it will show you the date it was created, the size of the image, the tag of the image, and the name of the image. So I want you to pull the Ubuntu image and the Alpine image and tell me the size difference between the two of them. I will call anybody to answer the question for me. So pull the Ubuntu image and the Alpine image. Pull them on your system. It has been pulled. So use Docker images to see information about all the images. So I said I'll call anybody to give me the size difference. Sorry, I have a question. Okay, fine. What's the difference between the Ubuntu and the Alpine image size?
What is that?
Difference. Did you pull the image?
Yes,
The Ubuntu image?
yes,
The Alpine image, did you pull it?
yes.
So what's the difference between the size?
That of Ubuntu is larger than Alpine.
Yeah,
So Alpine is more or less like a lighter version.
lighter version, yeah, exactly.
Between the size of the image and the real size of Ubuntu OS.
No. The size of the image and the Ubuntu image and the size of the Alpine image.
Ah, okay. No, I didn't pull the Alpine.
And pull the Alpine image and tell me the size difference. I'm com- Is it working? Okay, yeah, it's working. Docker is running.
Go back to
Yeah. Go back to your command. Yeah, the size difference.
70.3, right?
Okay, I can see. Yeah, like 70 MB.
Oh, but you asked us to only put one.
And also, I say put the Alpine image. So
Oh, okay, it's same code like Docker pull Alpine.
yeah, Alpine. Yeah.
Alright.
Okay.
Docker pull image.
Okay, it's working.
I tried Docker info, it's not working. It's telling me virtualization. I went to my BIOS, I enabled it. Then now it's
And
changing.
you need to start Docker. Docker is not running. That's the
I tried Docker, it's giving me an error. But the error actually redirects to the page. Then my restriction was being restricted. Do that updating and try.
So thank you very much. So someone already gave me the answer. It's 70.3 MB. So you can see 0.8. Okay, maybe because Windows lined up. Maybe Windows Mac. Maybe there's difference between calculate. Because it was 70. It was 77 for Ubuntu.
For what of this other?
Alpine was 7.
The difference is like 70 MB.
70 MB, yeah. 70. So now we've pulled the image. The next thing is to create a container from the image. So a container is a runnable instance of the image. You remember in the slide I discussed about this -IT. So it is to run an interactive shell. Normally, if I run the container, it will just give me the container ID and it will stop and run it in the background because Ubuntu has no log information to say. But if I want to start a shell, an interactive shell, I use the -IT. So Docker run -IT. Ubuntu, the name of the image. So you can see I have an Ubuntu OS running on my system with Docker. So any command I want to run on it, I can run on this Ubuntu image. Any command. So it's like I'm running a full Ubuntu operating system in Docker as a container. So this is a container running the root user and the host name also. So I can run any command ls dir. Oh no, dir is for Windows. What command? pwd / give me commands that you run in Linux. And you can, it's already a root user. Sudo is, it's already a root user. Git. Git. No need for password here. Just give me an Ubuntu command because this is a full Ubuntu system that we're running now. So I can type, okay, who am I? Who am I? So you should give me root. Yeah, I think. So this is a full Ubuntu system. So now let's check the containers that are running on our system. Now we have a container running on our system. Let's check it. So just open another terminal or another command prompt. For me, I'll just open another command prompt and do docker ps. Don't close the one you are running, the current one. Just open another terminal or another command prompt and docker ps. For me, I have a lot of things running. But you can see it here. Let me maximize it. So let me just highlight it. I'm coming. We've done that. No, no space, no space. Yeah, root user. Yeah. Yeah, open another terminal. Open another terminal. Yeah, you can open several terminals now. Docker PS. So it will show you the list of running containers on your system. So the command we run, docker run -it Ubuntu, created an Ubuntu container from the Ubuntu image for us. So now we want to see the number of running containers, the list, the information about the running containers on our system. So as you can see here, the first one is the container ID. Mind the break because of the size of the screen. So this is the container ID. It always has this format here of alphanumeric characters. So then you see the image name, Ubuntu. So this is the image it's using to create the container. You see the command it's using. So every Docker image has a start command. We will get there soon when we are creating. Okay. So open a new terminal. Leaving the one that is running. Open a new terminal and type docker ps, docker space ps. So you see the created status when it was created about a minute ago. You see the status, it means it's up. Up port, any port that you map to it, because you can map ports from your container to your system. So you can map a port. Then, I mentioned the name. So it gave me a default name, Vigilant Bonnell. So all containers have an ID and a name. It's very important because we'll be using this. Yeah, it will be different. It will be different. A name and an ID. So it's just, you can give it a name too. But if you don't give it a name, it will give it a name for you. I don't know. Mumbo. Yeah, isn't playground?
It's different. Bringing a new.
And because it's breaking to another line. So do it, type it again. Docker period. See it not break. So remember this docker ps command too. It's very useful. When you run a container, you type docker ps to see the status of your container. So you get all the information, the ID, the image name, the command that was used to start, the created, time it was created, the status, the ports that were mapped to it, and the name. Yeah, you can change the name when you are creating the container with the hyphen name command. So hyphen, then give it your chosen name. But be careful, two containers cannot have the same name. Yeah, so if you guys, so it will fail by the time you are creating the next one. It won't override. I don't think it will fail. But we can try it later, but it will fail. Yeah, it will fail. Okay. So I think we are progressing nicely. Um, so I think we should speed up a bit so that at least we can try and finish today. So go back to the former terminal. So this is just to try some commands in our new Ubuntu container. So we can use the cat command to create a text file in the container. So create a file with the cat command. So when you type this command, it will allow you to type in a list of characters. And when you are done, you just press Ctrl C. So cat, then we talked about this direction symbols. This one will open and create a new file for you with the with the greater than symbol and test.txt. So this one append it to create a new one based on what we learned this morning. So when you type it, so you can type a list of characters. Just to type a list of characters in the file. Then when you are done, Ctrl C. So this is all in the container. We are creating all this in the container. So we can ls to see the files in our container. So you can see the test.txt. So let's see the content of the file. We can use more text.txt. So we see the contents of the file. So you can try various number of Ubuntu commands on this, but this is not the way we use it. This isn't the way we use it. So this is just practical. Normally we use Ubuntu as a base image, and we install some commands on it. I said these containers are like layers of stacked images. So this is like the Ubuntu with like the first stack, the base stack. Like when you are building a house, you have your foundation. That's the first thing. So Ubuntu will be the foundation. Then I don't know how to build that, but you do your someone should help me who knows how to build that. But normally foundation is the base image. Then you now stack on it different commands on it until you have a full house. So this is just for practice. This isn't the way we use Docker containers. So this is just for practice. So we get there. So I think we have several commands we can run. We've seen Docker PS to list the running commands. Then we have Docker PS-A to list both the stopped and the exited and the running commands. They can also create and start container from the Alpine container. Okay, we can create a container with the chosen name, and with all the commands we're talking about in the slide. We can also try it. Please try it when you get home. So you can try when you get home. So you can create, if you want to give your container its own name, this is how you do it. Ctrl C. So if I want to give my container my own name, so I can use this -, name, chosen name, -rm Alpine. So if I want to run another terminal in my container, this is what I use, the docker exec command I use. If I want to stop a container gracefully, it's just to stop docker stop container. So we can stop the container we are running. If you want to do that, we can do that. So you can use anyone, the ID or the name. It just uniquely identifies the container. So let's stop our Ubuntu container. Let's try that together. So for me, I have the Ubuntu container running here. It's still running. So if I want to stop it, I can just do, okay, I want to know what is the name of the container or what is the ID of the container. I can just do docker ps. So sorry that you have a lot of information from me. So this is it. So this is the container ID. I can use it as the container ID or the Docker name to stop the container. So let's stop it. So you can see here in this format one, it's still running. This is still the Docker container root at the host name and the directory. So Docker stop. Let me copy the name. I'm coming. So it will take a little while because so it has stopped. So if I go back to this, you see that I'm back to my normal shell. So the container has stopped. So if I do docker ps, you won't see it again in the list. So if I scroll, you can see that Docker image has gone. If I want to see the stopped container, I use docker ps-a. So you can see this is it here. Docker ps-a exited. It has stopped. So it's the highlighted one. So that's it. So when you get home in the evening, just try out these commands. I can put my email. So if you have errors, you just send me an email.
It's me, it's here. It's CApIC. I save it with CApIC, not. Okay, let me now. Now, if I write this CApIC, it will show up.
You can stop the container. Okay. Yeah, you can just post your question on the WhatsApp group so that I can respond to them. So you stop the container. So you will see the command. Scroll up. So this is the command. You can use the container ID or the container name. So when you type docker ps, it will show you the container ID and the container name. Just type docker ps. Yeah. Yeah. But open not in the container. Not in the container. This is the container. In a new terminal, you open another terminal. Yeah. Name, exactly. Can be used, yes. Yeah, so that's the ID, that's the name. So docker stop container. Yep. No, you run it in another terminal. So this is the container. You want to stop the container. You can't do it because you don't have Docker installed in the container. Yeah. Yeah, the name of the ID. Or the ID, yeah. So it will take a little bit time. Then to stop. It will print the name. Then stop. So it has stopped. So if you go back to the format terminal or command, you see that it has come out of that prompt. So that's it. Then you start the container again. So now you can use Docker start container. No, anyway, since you're in your root. No, you are in the container now. This is the container. You are in the container. So if you want to stop, you can't run. You have to do it here to come out of this container. So when you're outside the container, you can run any command you want. Yeah. Yes. So you just printed the log for you. Um, okay. So now the last thing we did was to stop the container. So the last thing we did was to stop the container with the docker stop command. So if you want to restart that container, let's say you want to start it again. You were asking me a question, my guys in front, that if it's container ID or if it's container name, to start a container with the docker start command. So if you want to start that container that you stopped again, you just use docker start, then the container ID or the container name. So to get an exited container ID or the container name, you use docker ps-a. Let me just type it. Okay, it's just that my own is. So if I want to get all containers that have exited and the ones that are running together, I use docker ps-a. So it will show me all the containers that have exited and that are running together. So this shows me all the containers that are running. So you can see this was the Ubuntu that I ran and I stopped. So this is the container ID and this is the container name. So let's say I want to start this container again. I stopped it before. I want to start it again. I just pick the name or the ID. The name is easier because the ID is alphanumeric. So I just copy the name of the container, and I come here and put docker start. With the name of the container. Docker starts with the name of the container. So this will start the container, but it will be in the background. It will start the container, but it will be in the background. So if I want to check the running containers, I use docker ps. These commands are important. If you want to check list of running containers, use docker ps. If you want to check list of running and exited containers, use docker ps-a. Yeah. So I want to check if my containers is running. So let's see. So you can see a status up. Up means it's running 23 seconds. So if I want to get my terminal back into the container, before we were typing commands into the container. If I want to get it, so this is the command to use. If I want to get my terminal access into the container, when we started the image, we could type commands because we use the -it. Yeah, so we use this -it. So it helps us create a terminal access into the container. So if I want to do that again with a container running in the background, I use docker exec. This. So anywhere you see container ID, you can also use container name. Just note that. If you see where you see container ID, you can also use container name. If you see container name, you can use container ID. So to get my terminal access or my bash access to the container ID, okay. So docker run -it, but to this one you are creating and starting the image. You are creating and starting the container, not image, sorry, the container. So this IT means you want it to start with a bash access or a shell access or a prompt. I don't know the word to use. Is it prompt or shell access or terminal access? So immediately you start the container, it will give you a terminal access that you can type a command. Normally you don't start the container with this terminal access. You just start it and it runs in the background. But with this /it -it, it means you are starting it and you want it to give you a terminal access, a prompt access. So, but with this exec, your container is running in the background. It's running in the background, and you still want a terminal access. You didn't start with -it. You want it to have a terminal access as it's running in the background. So you use this docker exec. This docker exec means run this command in the container and give it a terminal access. So that's what this -it is for. To give it a terminal access or a prompt. Yeah. Yeah, so bash is the name of the command. You can actually run any command here. You can root sh, bash, any command you can run in a command. You can put top. Any command you can run in a Ubuntu system. So let me try it so that you see. So I just need the container name. So the container name is Vigilant Bonnell. So as I said before, exec means run this command, this bash command in the container, in this container, and give it a terminal access. This -it means give it a terminal access. So you can see I have my terminal access again. So with the name root then the host name, I can now run my commands in it. So that you just see that this is, you can run any command with this bash. I can also put top here and to just run the top for me. It can be any command. This docker exec is not only for opening terminal, it's for running commands inside the container. If I want to run a command in the container, I use the docker exec and the name of the container and the command I want to run. So this -it is if I want to have a terminal access into the container. Control C, or you stop the container. You can use Control C to exit it. But if you don't want to, if you want to stop it, then you just go to another terminal and type docker stop, then the name of the container or the ID of the container. Let's move on with the slides so we can actually build our own image. So you can just finish the practical in your own, at your own convenience. So Docker file, building your own Docker image. So we know Docker image is a template for creating containers. It contains all the instruction that Docker will use to create a container for you. So how do we build this image? What's the process of building this image? What are the techniques of building this image? So as I've said, a Docker image is a template that contains a set of instructions for creating a container that can be run on the Docker platform. It provides a convenient way to package up applications. As you can see, I highlighted package up, used to package containers and pre-configure the environment to suit the application, which you can use for your own private use, or you can share publicly with other Docker users. So Docker files are the way we use to create Docker image. So the Docker file is an important word, Docker file. So there are text files in which we use to create a Docker image. So important things to note. It is used to package up applications and pre-configure the environment. Then we use a Docker file, which is a text file, to create an image. Okay, an analogy. Let's say I have an operating system. I have a new laptop, it has no operating system at all. How do I install Chrome.exe in the laptop? I want Chrome, but this laptop has no operating system. It's a FreeDOS laptop. There's no operating system on it. So how do I do that? So we can use that same analogy in building an application for Docker image. So the first thing you do if you want to install Chrome is to install an operating system. It can be Windows, it can be Linux, it can be our Orga desktop Mac OS. So the next thing you said, so you can see you specify a base image, which is your operating system. So in our Docker files too, we'll be specifying a base image in which we used for an application. Then you start your default browser. Then you navigate to chrome.google.com in your default browser. Then you download an installer. You open the file or folder, your downloads file or folder. Then you execute install.exe. You can see all these are commands to install the program. All these are commands to install the program. First, you specify a base image, which is your operating system. Then you have step-by-step commands. You can see they are also in layers, because this is important. Layer 1, layer 2. And it's in the slide. Layer 2, layer 3, layer 4, layer 5. So you can see they are all commands you run to install your Chrome.exe. The target is to install Chrome. Then the last one is to execute Chrome.exe. So which is your command to start up, to run on startup. So I want us to notice these three things in this analogy. You specify a base image, you run commands to install additional program, and you specify a startup command. So these are the three things we use in building a Docker image. So let's see an example Docker image here. So this is a Docker image, a Docker file we use in starting a Node.js server. So you can see here we are specifying a base image. So I want to create a Node.js server. Please, do we know Node.js? Node.js is a server API runtime. I don't know if I explained it well. So it's just for creating APIs for servers, so you can access a resource and send back response. So we know what is it. So I want to create a server, a Node.js server. So the first thing I do, I specify a base image, which is Node. I know we have seen this Alpine before. So it's telling me this node is based on Alpine. And Alpine is based on Ubuntu, a stripped down version of Ubuntu. So I'm specifying this image. This is the base image. So anytime you are building a Docker file, you specify a base image. It's very important. Then the next thing, the setup steps and commands to install additional programs. So all the things, I said a container is you have a base image and the steps you use to pre-configure the command, the image, the steps you use to pre-configure the image. So these are all steps we use to pre-configure our environment so we can run our Node.js server. If you are not understanding, you can pull me back. So let me go back to the previous slide. If we want to install Chrome.exe, we specify a base image, install operating system. Then all the necessary steps we need to run Chrome.exe, we do them. Then the last thing is to execute Chrome.exe. So same thing for a Docker image for Node.js, for building a Node.js server. We specify the base image. Then all the necessary steps we need to build the Node.js server. These are this. This is just specifying an environment variable. This is specifying a working directory. This is copying this file to the part in the working directory. This is running some commands. This is exposing a port. This is copying all the files in the working directory to the working directory of this file. This is building the Node.js source. And this is specifying the start command. So that is the structure of a Docker file. It has a base image, the steps you use to configure the image, which are layers, and a startup command. So those are the three important things we need to create a Docker file or an image. Please, does anyone have questions? Or if you don't understand, okay.
So let's say I'm going to use our Chrome analogy. Now that I've installed Chrome, next time I want to visit my laptop, I don't need to install it all over again. I just want to open it. So how can I do the same thing with Docker?
So when you create your Docker file, you can build, your next thing is to build your image. So immediately you build your image, you can use it anywhere. So this Ubuntu image that we used, this is how it will be. It will have a file like this, a Docker file like this. So it was built and the image was pushed to the Docker hub. You can always change your Docker file. You can add some extra things. You can build it as many times as you want. But if you are building again, Docker has some intelligence so that it doesn't redo a process again. So if it sees it has been done before, it won't redo it. It will just use it and build the next step for you. Okay.
Like, if you go to Docker Hub is where images are stored. You will see different versions. Like Ubuntu now, there are different versions of Ubuntu. So, meaning that if you have additional information to add for your Docker, to create maybe another instance of Docker image, it will be a new version. Like the Ubuntu that we put now was the latest version of Ubuntu. But if you are interested in lower versions, they are available on the Docker Hub. You understand? So what we are trying to do now, we can as well finish it and push it to Docker Hub too. so that others can pick it up and use. So I think I just wanted to.
Yes, that's very correct. So we have different versions. So if we want to create our own versions, we would tag the image. So when we are getting to build our own Docker file, we will notice we can build different versions by tagging the image. So any other questions?
In your example, I see the node, the base image is coming from the node. Is it a server typically or not?
No.
What does it? Yeah.
It's also an image.
No, the 14.15.4.
Okay. So it's an image containing node. So it contains node 14.15.4. You know, we have different node versions. So it contains node the 14.15.4 installed upon Alpine 3.10. So in this node .14.15.4, it is also a Docker file. In that Docker file, there's a base image. That base image is Alpine 3.10.
This node is where in the cloud.
It's in the Docker hub. You can access any image on the Docker hub. So if you go to Docker hub and paste this line, you will see this image. Yeah. So 3 things I want us to notice here. The base image, we always specify a base image. Here we are trying to build a Node.js server. So the base image we have to use has to be something related to Node.js. So we are using node 14.15.4 built upon Alpine 3.10. Then the next thing is a set of steps we use to configure the server. So here we have the set of steps. And the last thing is the startup command. All images have a startup command. I think it's clear. Let me just go over it one more time. From the analogy, again, we want to install Chrome operating system. So the first thing we do is to install on a laptop that has no operating system. The first thing to do, which is to specify a base image, is to install an operating system. So in your Docker file, this first thing, this image is like specifying the operating system of your Docker file, the base, the foundation of your Docker file. Then the next thing is to specify the commands to configure your base image, your environment, to the taste of the thing you want to do. Here we are trying to install Chrome.exe. So we are configuring our operating system to the taste of what we want to do. So these are the commands we run. So we have some run commands: start up your default browser, maybe Microsoft Edge, navigate to chrome.coco.com, download the installer, open the download file, execute the Chrome installer. So these are all used to configure our base operating system into what we want to do. And the last and final thing is to always specify a startup command, and which is executing Chrome.exe. So here we are trying to install a Node.js server to run our Node.js code. So we specify the base image, which is like our operating system. Then all the commands we need to configure the base image to run our server. And finally, the startup command. This is very important. So these 3 things are very important. So I'll be walking through all these different commands. This from env, workdir, copy. So these are the way you can pass commands to Docker to create a Docker file for you, or to create an image for you. To create an image for you. So your base image, your steps to configure the environment, and your startup command. So the first one we notice here is the from command. So as you can see in this Docker file, we have the from command. It's always the first thing you specify when trying to build a Docker file. So the from command, so you can see from image, the tag, and the face. This is as you should specify a face. So this is the face name. And I will talk about it. So the from instruction initializes a new build stage and sets the base image for subsequent instructions. A valid Docker file must always contain a from instruction, and the image must be a valid name. So as I have here, so this is the from instruction. It's specifying a base image, and this must be a valid base image from Docker Hub or hub.docker.com. It must always be a base image. When building a Docker file, you must start with a base image. So the from command is used to specify the base image that you want to start with. So these are the commands Docker has given us to use to create a Docker file. So we can see here we specify the image name. One thing is important, the tag. We can specify a tag. So there are different versions, as Prof said, there are different versions of images online. Like there are different, there are different versions of Python. There's Python 3.7, Python 3.8, Python 3.9. So on Docker Hub, we also have different versions of Python. So if I want to specify Python 3.7, is this tag I will use? I'll specify Python 3.7. In my example here, I'm using, you can see this colon, 14.15.4. So that is the tag of the image. I don't know if it's clear. So we have the image name, then we have this colon, then we have the tag. So no, it's a different version of your image. It's just a different version, but it is tagged so that you can use it to know which version to pick. So it is tagged. So this tag is used to specify different versions of your image. So you can see here I'm using node. Node is the name of my image. Then I'm using the tag, the colon 14.15.4. -IPAN. So from here to here is a tag. So when you go to up.docker.com, you can see different versions of Node. There's, I think the latest is 18 or so. 18, 15, 16, 14, 12, up to 8. So you can see different versions, depends on what you want to use. And this is what makes Docker useful. You know, I said in the beginning of the course, who's calling me? Sorry. Okay, so you can use the different tags. You can use the different tags to specify a specific version of the image. As I said in the beginning of the course, that one of the importance of Docker is that you can have different, you can lock in a particular version on your local, on the container on your local system and the container on your remote server. So let's say on my local system, I want to work with Python 3.7. This is where I'll specify it. So I'll specify Python 3.7. Then by the time I move this image to my server, it will just pull Python 3.7 also. So this is the way we lock in a particular version of a particular image in our Docker file. I don't know if it's clear. So the from command is used to specify that base image. So this as a tag that I have seen about, so it is used to build different phases. So let's say I want to have different phases, like phase 1, phase 2 on my Docker image, and I want to use the output of one phase as input into another phase in my Docker file. I can use this as command, as command. So this is useful in building multi-step images where the data from one phase will be used in another phase. We'll be seeing an example. So let's say I want to use the output of this, like this npm run build now. It's going to spit out some files. So let's say I want to use that file. Let's say I want to use that file in a new phase. Let's say I want to use that file in a new phase. So this as command enables us to use that. So we'll be seeing an example of it. I think examples will help us understand better. So these are the different ways you can specify your base image from Alpine, from Node 16. So this is specifying a specific image and the tag of that image. So this is the way we lock in a particular version of image on our Docker file. Okay. Yes. So this Alpine, this is the image that we're using as a base image. So this one we're using node as the base image, but the tag, this is the tag. So this means this is node 16 built on top of an Alpine 3.11 image, Ubuntu image. So it's clear. Okay. Yes, you can create a Docker file. You can build your node on any operating system image. Yes, you can take like this node 16 half an app. I can use it as a base image. That's actually what I'm using. So here I'm using node 14.15.4 Alpine.3.10 as the base image. This image that I'm building here, I can use it as a base image for another image. You get? So your from command is used to specify a base image, and it must be a valid base image for it to work. Okay, I think that's an internal question for Docker. So by the time you put it, Docker will test, is this a valid image? And to give you. But normally, you have your images on Docker Hub. You can also push your own image to Docker Hub. Yes. Yes, you can also find your own image from Docker Hub. So you can specify Debian. You can also put the tag, meaning the version of Debian you want. So the colon is used to specify the tag, meaning the SR version of Debian you want. So there are different repositories or registries. There are different registries, but the common one and the default one is Docker Hub. I've forgotten the name of another one. Then you build your own image on that image. Then when you build your own image, you can push your image to Docker Hub, and you can also use it. You can also get it from there, and also use it as a base image for another image. So Docker works as layers of stacked images. So there are layers. Okay, yes, there's an official repository. So which is ob.docker.com. That's the official repository or registry.com. So we'll be creating an account on ob.docker.com, every one of us, so we can push our own images to Docker also. So there's something I want to say. So the way Docker works is that it builds layers of stacked images. It builds layers. So the first thing you specify is your foundation, which is used with the from command. So if you want to build another layer on your image, you use any subsequent command, like for example, the run command. So it can take any of the following form: run, then the name of the command. That means the shell form, and the command is run in a shell, or the run command and the executable. So it can be in this form or this form. I don't know if it's clear. So these are examples here. Run, then the name of the command you want to run. Then these two are together. So I can put, let me see if I have, this is one, okay, this is a multi-line command. I can do bin bash -c echo hello. I can remove this bin bash and just put run echo hello. I can do run who am I or run pwd, but these are not useful for building Docker images. We want to build layers on top of our base image. So we want to maybe install something on our base image. So that's why we use the run command. So run instruction will execute any command in a layer on top of the current image and commit the results. So let's say we have our base image and we want to, as I was giving the example, we want to create a Node.js server. So that's our goal. We want to create a Node.js server. So we have our base image. We have specified our base image as Node.js 14 or Node.js 16. So the next thing we want to do maybe to install the dependencies of Node.js. Or I don't know what example I can use that will be closer to you. Let's say we want to create a Python program and we have used Python 3.7 as the base image, because you can use Python. There's a lot of Python versions on Docker Hub. You can also check them out. So Python 3.7. So the next thing to do will be to install the dependencies and run some commands that configure your base image. So to install dependencies or to run any command on your base image, we use the run command, this RUN. So this one that you see bolding are commands that you can use to create, to build your images. From is a command provided by Docker. Run is another command. We'll use it to run commands on our base images. I don't know if it's clear. So again, the run instruction will execute any commands in a new layer on top of our current image and commit the results. The resulting committed image will be used for the next step in the Docker file. So it's just that it will take your command, run it on the base image or on the previous layer and commit it and make it ready for the next layer. That's what run does. So like in our analogy, the first thing is our base image, our operating system. We install our operating system. I think the next thing was to open our default browser. So we can just to run, that's the next action you do. Run, open default browser. So that's an action. So it is done on top of the operating system, on top of the base image. So it is the same thing here. We specify our base image with from. Then the next thing is to run a command on top of that from, on top of that base image, which is, we use the run command to do this. I don't know if it's clear. Practical. But this is the theory. We will still get to practical. This is just the theory aspect. This is just to show you the commands, because by the time I start typing for you, like if I type this file out for you now, you might be saying, what is expose? What is work dir? What is copy? So I'm trying to discuss these commands for you. What is run? What is run? What is cmd? So all these commands are what you use in your Docker file to create an image. So this is just the theory aspect. So there's the theory and the practical. Okay. Okay. So let's say we have a house and we have rooms in the house. So let's say we want to, how will I say it? We have an image and we are building a container from that image. So let's say the image is a house and we want to build a room for that house. So we can use that image that we've created the container from. We can use it as a base image for another container. Yes, it can be another container. For example, this node colon 16, this node colon 14.15.4 Alpine 3.10 is just telling you that this node has this version and was built on top of this Alpine image. So in this node image, the Alpine image was used as the base image, and we are using this old one as our own base image. Yes, you created. You yeah, your version number of your own Docker file, own image. S- Yes, sir. Yes, sir.
Definitely, you need a base operating system like the AppICE.
Yes,
Then you need a server,
yes.
which is what the node is doing. Then eventually, the image, your own app now will sit on the node.
On the node, yeah.
Because node is the web server, and the web server must have an operating system.
Operating system, yes.
So
Yes.
just the example you gave is actually very clear. The analogy creates perfect illustration. Yeah.
So let's move on. So when I have the base image, I want to configure the image so that I can get my result. In this case, a Node.js server. So I can run commands. I want to run commands on that base image. I want to run commands on it. So to run commands on a base image or on any layer, because it doesn't have to be the base image, I can use this run command, run npl install. So as you can see here I'm specifying some commands here, and I'm using this run. So this run npl install, this just means install the dependencies of this project, of the project I'm running. So here I'm copying this file, package.json. Package.json in Node.js specify the dependencies of a particular program. So I'm copying it into the working directory of the image, and I'm installing the dependencies. So this run is used to install dependencies or install programs or install, I don't know which word to use, setups on top of the base image. So we'll be getting to examples. So the next one is work dir. So let's say I want to specify a working directory, or it's used to specify a working directory so that any subsequent commands will be run from that working directory. So let's say I have a folder now, and I want to install some things in that folder. So I will specify that folder as a working directory, and I will install everything based on that working directory. So work dir. So this is the format, path to the working directory. We can see the example here. So this just means create this /app as my working directory. We all know what a working directory is now. Like if you do pwd, it means print working directory. We all know that, right? So this work dir is like setting for the image, make this /app the working directory of my image. So work dir sets the working directory for any command, for any run command, copy command, or add command that follows in the Docker file. It creates the working directory, and everything executed will be in that directory. So all the commands I execute will be based on that working directory. So the next one is expose. Let's say I want to expose a port. Maybe my application uses a port. Most things they use Docker for is for web servers. Actually, most times it's for web servers, and these web servers expose ports. So if I want to expose a port in my application, I use this expose command. So you should tell the image, the Docker config, that this port is to be exposed for my application, for my container. This port is to be exposed. So the expose instruction informs Docker that the container listens on the specified network ports at runtime. But note one thing, the expose instruction does not actually publish the port. So if I run my image and I create a container from it, me specify the expose command in the Docker image doesn't actually expose the port. To actually expose the port, I must use this -p command as I used here. Docker run is used to create an image, if you all remember. Who remembers what this -d does? It's to run in background. It's to run the image in background. So I'm publishing the port here. I'm publishing it port 80. This is my host port. And port 4000, my container port. I hope it's clear. In my application here, I'm exposing port 4000, meaning my application, my web server is listening on port 4000. So I'm exposing port 4000 here and exposing it on port. I'm mapping port 4000, I'm mapping it to port 80 on my local system. Okay. Yeah, so every request coming on port 80, as is specified there, will be directed, to port 4000 in the container. Yeah, that's just the meaning. Every request coming on port 80, which is the default HTTP port, will be directed to port 4000 in the container. Who remembers what this hyphen name does? What does it do? This is a simple one now. Huh? What does this hyphen name do? And the name of the container. Just simple question. So copy. So this is another command we use for creating a Docker image. So you just mean copy from a source to a destination. Copy from a source to a destination. When creating a Docker image, you specify a context. That context just means your directory that you're running the Docker image. It means your directory. So it means copy a file from that directory to your working directory in the image. So here we specify a working directory as /app. So it means in the image you create a /app. Then I'm saying copy this package.json. There will be a file called package.json in my current working directory on the local system. And I'm telling it copy it to this /. So this / means copy it to the current / to the current working directory in the container. In the /app in the image. So this is specifying the working directory and it is copying it to the current working directory in the image. Is it clear? So that's what the copy command does. You can see it here again. This just means, you know what the dot is in Linux now. What does dot mean? Current directory. So it means in my current directory, copy all files in my current directory to the current directory in my image. What is the current directory in my image? App. So I've specified it here as workdir /app. So that's what workdir does. Specify a current working directory for your image. So when you are building your image, you specify a context. That context specifies the directory that the Docker will copy files from. So you are telling Docker, okay, this is my context. This context is the directory I want you to get this file from. So in my context, I will get there later. In my context, that means this package.json has to be there. If it's not there, it will throw error that specify the correct file for me to copy from. So we'll get to context later. I hope people online are following too. If you have questions, just raise your hand online. And people here too. So copy copies instruction. The copy instruction copies new files or directories from the source, which is your local system, and adds them to the file system in the container at the path in the destination. So it copies from your local system to the container. I hope it's clear. It copies new files from the source. So you specify a source and you specify a destination. It will copy the file from the source. Your source is your local system, your context that you have specified. It will copy it to the destination, which is your container. So the parts of the files and directory will be interpreted as relative to the source of the context of the build. So as I've said, there's a context. Your context is the current working directory you have specified for Docker to copy files from. So all the files you specify in your source will be relative to that directory. Most times you just specify your current working directory, you just put a dot, which means your current working directory. So the destination is the absolute path or the relative or a relative path to the work dir. You know, I said this work dir. So by the time you specify your work dir, you are specifying a current working directory for the container. That means, okay, this /app is the current working directory. Let me show it again. So work dir means you are specifying a current working directory for your container. And that current working directory is /app. Is it clear? Okay, so the destination is an absolute path or a relative path to your work dir, which is your working directory in your container, into which the source will be copied inside the destination of the container. So it will copy files from your local system, your context, into the container. So that's what it does. We'll be seeing an example by the time we do our practical. So, you know, I said in our analogy, we have our base image, which is our operating system. Then we run some commands, which helps us configure our container. And we have a command, which is the start command of our system, of what we are trying to do. This is the base image. Then these are the commands we are using to configure in order to achieve our goal. And this is the startup command, the last thing that we do. So here, this CMD is used to specify the start command. The main purpose of a CMD is to provide defaults for executing a container. There can be only one CMD instruction in a Docker file. If you list more than one, the CMD, then only the last command will take effect. So this CMD is used to specify the command that we run when you start your container. You know, when we ran Ubuntu, we saw start command bin bash. It means start bash. So this CMD is used to specify that start command. I don't know if it's clear. So it's just like an analogy. We put execute chrome.exe to start our Chrome browser. So this CMD is the similar one. It's used to specify the start command. In my example Docker file, you can see here npm start. npm start is used to start our Node.js web server. Okay. So we are having example Docker file. So this is the Docker file I've been showing since the beginning. So again, first one, for a Docker file, if you are trying to build an image, you specify the base image. As you can see, I'm specifying it here. Node 14 with tag 14.15.4 -3.10. So this is my base image. I'm trying to create a Node.js server. If I'm trying to create a Django server, it's Python that'll be here, Python 3.7. If I'm trying to create a Laravel, I don't know what they use for Laravel or Java. I think if I'm trying to create a Spring Apache, Apache. If I'm trying to create a Spring application, it's Java that we have. So here I'm trying to create a Node server. So I'm having Node.js here. So these are steps I'll use to configure the Node.js server. So if it's a Python server, there will be steps to configure your Python server. So this specify environment variable, your working directory. That means I want my /app to be my working directory. My context, in my context, I'm copying this file from my context to my current working directory in the container. I'm installing the dependency with the run command. I'm exposing the port. I'm copying all the files in my context to my working directory of the container. I'm running another command to build my files and create the server. And I'm putting the start command. Let's go to another example. So this is another example. This one is much more complex. So, okay, simple question. Who can tell me what the base image is in this file? Okay, someone should just tell me. Anybody? Who wants to try? Who wants to? No, it's not correct. No, the full tell me the full base image. What is the base image of this file? Yeah, node colon 12 hyphen alpine. So, I said as is used to specify a phase. So this is the builder phase. I'm specifying a builder phase. What this phase does is that when I create the phase, all the inputs, all the outputs of the first phase will be passed as inputs into another phase. It allows me to specify multiple base images in my Docker file. So normally we should have one base image in our Docker file, but when we are using phases, it allows us to specify multiple base images in our Docker file. So as builder, everything under the as builder will be referred to as the builder phase. So this is our base image, node colon 12 hyphen alpine. 12 hyphen alpine is the tag or the version of which node we are using. Any subsequent command will be executed relative to this part in the container. So this is the working directory. Work dir is used to specify a working directory, and /app is the current working directory. So any subsequent command will be executed relative to this part in the container. So any subsequent command I run will be executed based on this working directory. Anytime you see work dir, it's used to specify a working directory. I hope that's clear. So now, copy. We talked about copy. Copy is used to copy files from your context. That means your local system. Let me just use local system, but the word you use in Docker is context. You used to copy file from your local system into the container. So here I'm copying package.json, which is just a file. It can be any file. This package.json is just what we use in Node.js, but it can be any file you want. It can be kunle.txt or folake.txt. So I can copy this file into, who can tell me what this dot slash is? What is the current directory? App, very correct. So I'm copying this package.json from my local system into the container, which is the /app folder. So here I'm installing all dependencies. So I'm using the run command. So if I want to run anything, it can be anything. I can run echo kunle echo bimbo here. So run, then now this is a command. Okay, I will tell that this is a command. The reason why this command is available is because it's available in this node image. I won't be able to run this command if I'm using just Alpine. If I'm using just Alpine image. So because they've bundled all these node specific commands in this image, that is why I'm able to use this yarn install. So if I want to run a specific node Ubuntu command, like we're running cat, we're running who am I? If I wanted to run it in my Docker file to run when I'm building it, I'll just put to run who am I? And who am I is available here because it's present in our base image. So this is like specifying the operating system of our image. You get? It's like specifying the operating system, the base image of our image. So all the commands available in this base image will be available in our Docker file and also subsequently in our container. So run is used to run a command. So in this case, we are installing dependencies. So copy dot we are copying files from our local system to the working directory in our container. So this dots means just copy all the files, copy everything. Okay, so run another command. So this yarn is present because it's available in our node image. Yarn run build just means build the project for me. Build it. I know some of us are programmers. So let's say I have a class now and I want to build it. I've created my class, I want to build it. Maybe I'm using Java and I want to turn it to, is it Javac? Or what do you, bytecode? There's a command you use to convert to the bytecode. For Node.js, this is the command you use, yarn run build. I use the command into a language that my compiler will understand. So that's what this yarn run build is doing. So that phase ends. You can see I'm using another image here, from. From is used to specify the base image. Anywhere you see from, is specifying base image. So we are having two froms in this Docker file. So we are having two phases. So that's why we are using another from. Now I specify as builder. So this is the first phase using this from. So this is the second phase. From means starts a new phase. So we're using ng-inx. ng-inx is a web server. Is a web server. So we're exposing port 3000. So I'm telling that, okay, container, this port will be is to be exposed when they are running. Expose port 3000. So copy just means copies a file from local system to our container. But this time, it's not copying from local system, it's copying from the container into this part. So this is just needed for ng-inx to work. But copy command is important to note here. Then look at this copy. You can see from builder phase. So npm, so this is the output of npm run build. From this yarn run build, this is the output build. We are copying it into a directory that ng-inx will be able to use. So copy is used to copy a file from your local directory or even from your container into another directory. So those are example Docker files. So that's the way to create Docker files. Okay, building Docker images. Now that I've created my Docker file, I've created it, I need to build it into an image. I've created the template for this Docker file is like a template for building images. Now I want to turn it to an image because it's not yet an image like this. This file is not an image. This is just a Docker file specifying the template in which to build your image. I hope that's clear. So this is just specifying the template. It's just telling, by the time I do this, I'm passing it to the Docker server, the daemon. So the daemon will pick this file one by one. This line will pick each line one by one and build my image for me. So to build a Docker image, we use this command, docker build, the name of your Docker file. And you remember I was saying something about context, your context. So Docker file is expected to be in the working directory where you run this command. So the current working directory where you run the command, your Docker file should be there. This is a Docker file. This full file, you can see the file name, Docker file. So this is a Docker file. This is also a Docker file, specifying the instructions which you use to run, to create an image. So if you don't have the Docker file in your current working directory, you can use the -f flag to specify the path. As I specified the Docker build -f path to a Docker file, and dot, which specifies the current working directory. I'm telling you that this is my context. So the build context is the set of files at a specified location or URL to be used in the Docker file. I hope you get that. It's a set of files at a specified location. So in this case, it's our current working directory. Or it can also be a URL. In case you have a link, a URL, it can be a GitHub URL. The URL can also be a Git repository location. But the path is a directory on your local system. So if you want to exclude some files, from this part, you use the docker ignore file. So you specify the files you want to exclude. For those of us that use GitHub, there's a git ignore files. If you want to ignore some files from being pushed to your repository, you can use a .git ignore file and to exclude those files. So it's the same concept here. If I want to ignore some files from being copied, like for example now, in this place, okay, this place, I put copy dot dot. This copy dot dot means copy all files in the local directory of my context into the app directory of my container. But if I want to exclude some files, I'll use the docker ignore file. So to specify a repository and the tag to which to save the new image, we use the /t. You know, I've been seeing our images have tags. For example, here. So this is a tag, :12-alpine. That's a tag. So in my own image, if I want to specify a tag, I will use this /t. So this is the way I specify a tag. So I can use my Docker ID or repository name, your app name, then colon. So this is my tag, my version and tag, and this is my context. So if I want to build a Docker image, I put Docker file, Docker build -t, specifying the tag, all the information I need, the tag, and specifying the name, then the tag and the context. Who can tell me what the context is? Okay, yeah, it's still on the slide, Sham. The build context specifies the set of files at the specified location or path to be used in your Docker file. So context here is my current working directory. So we're doing this in the practical. Okay, I think most of us have gone to Docker Hub. So in your private time, I want you to create an account on Docker Hub. So this repository ID, this is a repository ID. So when you create your own ID, your own account on Docker Hub, you can use it as a repository ID. Yeah. So this will allow you to push your own image to Docker Hub, because anyone can push images on Docker Hub. It will allow you to push images. So we'll be practicing pushing images later in Docker when we are doing our practicals. Building images and pushing images. So before we start building images, there are some things I want to talk about, like Docker volumes. So when you start your container, like we built Ubuntu container, when we start our container, if, like, you remember, we created a test.txt file. If you stop the container and you delete the container, if you try to create the container again, all the information is lost. All the information is gone. So that's the way things are with container. Data generated in containers are not persisted. They are lost when the container is removed. But if you want to persist this data, if you want to keep this data, you use Docker volumes. So volumes are files or folders on the host machine that are mapped onto containers. So we have our files on our local machine is mapped onto the container, and this allows you to save information about your container on your local machine. Volumes allows us to persist data even if the container shuts down. When the container restarts, any data changes made in the volume is made available in the container. I think that's straightforward. So there are different types of volumes you can create. There's the anonymous one, but it's not so useful. But the first one is the named volume. Named volume, you give the volume a name. So to create a volume, when you are running your Docker run command, -d, -rm, -name. So these are all commands we are specifying for Docker run. This means run in the background. This means remove the container when it is stopped. This means create a name. Use this name for the container when you are running it. So to specify a volume, so that your data in the container is persisted, is kept when you are restarting it again, you use this. So this is a named volume. So the name of the volume and the path you want to be persisted in the container. So anything in this part will be persisted. So Docker will create this name volume somewhere hidden on your system. It will create that volume for you. And everything in this part in the container will be saved for you. So that's the way of creating a name volumes. So name volumes are persisted even though the container is stopped or removed. So we all know why these volumes are important. They are used for persisting data of your container, because when you run your container and you stop it and you remove it, all the data is lost. So to save data of your container, we use this name volume. So this is another example. So this -d to run in background, -p to port map, rm to remove when the container is stopped, name to specify the name of the container. Here we are creating a name volume. It means give this volume a name, and this /app feedback in the container should be persisted. So the files in /app/feedback will be persisted somewhere in your system that is not even known to you. If you try to find it, it will be hard to find. But there's another type of volume you can create that you can map data from your system directly to your container, that you see the files in your system also in your containers. So to see the volumes on your system, that is Docker volume ls. So you see all the volumes on your system. So bind mounts is when you can see the files on your in your local system in your container. But is a type of volume used for during development of a code base. It helps to synchronize the context of files and folders in your host computer with the files in your container. So if you have some files in your host system, it can help you synchronize those files in your container. Let's say as a programmer now, I'm building some code, I'm writing some Java code, and I want the code to update in my container. I can use a bind mount to do that. I don't know if it's clear. So it helps you to synchronize files on your local system into your container. So files you have in your local system, you can see in your container. You know there are two different things. Your container is different from your local system. So files you have in your container, it can help you see them. A bind mount can help you see them in your local system. So to create a bind mount, there are different ways of creating this volume. A name volume is created like this. You just specify any name you want, and the parts in your container. That's the way of creating a name volume. But a bind mount is different. You specify a full path to that folder you want to map into your container. You specify the full path and the part in your container. Okay, this is a mistake. It's supposed to be a slash here. So we can see example here, -v. This is the full part of my system. Full part :/id. So this is the part in my container. So this file like this folder db_r is mapped into my container. So all the files in this folder will be available in my container. So we can also map a file. If you just want a file, not a folder, we can also map a file into our container. So these are all the files. I mean, this is the full path to a file. You can see local to path.txt. I'm mapping it to home/input.txt. If I want to map a file into my container, so that's what I do. So this doesn't just work automatically for Mac and Linux user. You have to go to your Docker desktop settings and ensure file sharing is turned on. This system doesn't also work correctly on Windows. By the time you activate it, it will give you some errors, but there's a specific type of file path you have to use. So you use this file path. Normally, I should just use C users, .ref documents, and it will work for Mac and Ubuntu. But for Windows user, you have to use this prefix for it to work correctly. So when we get there, we'll see in the practicals, if you have time. So the next one is Docker networks. So normally we have different containers. Container 1, container 2, container 3. How can they talk to each other? They all have ports. How can they want them to be able to communicate with each other? What way can they communicate? So we can use a Docker network to enable them talk to each other. So Docker network allows communication between several isolated containers, as container connection is not automatic. So because you created containers on your system, that doesn't mean I can reach container A from container B. I have to create a network to allow them to communicate. So each container, Docker automatically does IP resolution and DNS resolution. So each container will have an IP and will have a host name given to them. You know, when you type a URL on your system, it goes to a DNS server that converts it to an IP address that your links to a particular server. So in this case, your container name will be your URL. And Docker has some DNS resolution system in it that will convert your host name, your container name, into an IP that can be used to talk to another container. So it does some kind of DNS resolution in it. So to create a network, you do Docker network create, and this is the name of the network. So I think that will be the next thing, practicals. Okay, we'll be doing a small project now with Dockerizing these services. So this is a full stack application. So we have our browser, which will be talking to an NGINX server, and we'll be redirecting traffic to our NGINX server, to our backend server and our frontend server. And our backend will be talking to a database. So this all will be containers: container 1, container 2, container 3, container 4. So we're creating 4 different containers, and they will all be talking to each other. You know, if you have a database, you need to persist data in the database, because if your container stops, all the data is lost. So if you don't persist data in your database, all your data will be lost. So we're using Docker volumes for that also. So I think it's time for some practicals. But before I go to the practicals, any questions? I hope you guys were able to understand. Any questions? Okay.
Okay, my question is, when I pull, for example, the image, Ubuntu image, I was trying to install, for example, the DHCP package, but it didn't work. Yes, I update, and after I trying to install the bind package, it not also work. Yes.
Okay. Yeah. So you have to put the repository name where it can find this package from. You have to put that. So you read the documentation of the DHCP well. So for new Ubuntu, for some Ubuntu, it doesn't automatically come with all the places to download packages from. So you have to put it beside the package, and it knows where to put it from. Yeah. So when you do that, then you update it, and you'll be able to find the program you're looking for. Okay. Any other question, please? Thank you. So let me just run the practicals for you. Let me just show you go through some Docker files with you. And if time permits, we'll run the practicals ourselves. So I think I even put sufficient. Let me check. So what we are working on is multi-container. Okay, I put a text file there. Okay, so these are the commands we'll be running now. So we'll be building images. and we'll be running those images. So this time we are building our own images and we'll be running those images. So, but first, we want these images to talk to each other. We want these containers to talk to each other. We want them to talk to each other. So the first thing we'll be doing is to create a network. But first, let's go across all these images. Let's just see them. So the first one, okay, is a database, our Postgres database. So for that, we don't need a Docker file because there's already a Docker file available on Docker Hub for us. So we just run the image and specify our arguments into those images. So here, we are specifying a name for the database. Here, we are specifying environment variables. So our Postgres image needs some environment variable to create the container when it is starting up. So this is it. So this is one of the environment variables is Postgres password. So this is how you specify an environment variable -e. So this just allows you to make your container more configurable. To make it more configurable. So this /e is used to specify an environment variable. We know what an environment variable is, right? Environment variable. So these are variables that are available to you in your containers that are specified, that are not specified in your application, but are specified in the system and are available to the application. Okay. So as I said, for a database, it needs a volume because you need to back up your data. Not back up, you need a volume to store, to persist your data. You need a volume to persist your data. So here we're creating we can tell what kind of volume is this. I think I explained it. I showed two types of volume. One was a named volume and one was a bind mount. Who can tell me what type of volume is this? To show that you were listening. No. There are two types of volumes, named volumes and bind mounts. So named volumes, you specify a name and the path in your container. Bind mount, you specify the full path in your local system and the path you want it to be in your container. So this is a named volume because I'm just specifying a name here, as you can see. I'm specifying a name here. Column, the path I want it to back up in the container. It don't just back up everything in the container. It is the path you specify that it will back up for you. I hope you get. So I've been explaining this /rm for you. Who can tell me what it is? -rm, -rm. Yeah. When you stop the container, it will remove it for you because it doesn't automatically remove it for you. So when you specify this -rm, it removes it for you.
Okay. And this is the kind of feedback that we're talking about. So are we all saturated? Was it talking for everybody? Let's be sincere and be opened. Dr. Dab, you're also saying yes. Okay, it's actually almost 5 anyway. Maybe tea break, another tea break, then, or we should continue this tomorrow morning. Is that what we are saying? First thing tomorrow? Okay, because that tomorrow, I think, and it's also laying the foundation for other things that will come tomorrow. if you look at the theme of this workshop, maybe you should move a bit. That's why it has to go to this. I was telling you that the first, second day, we're scratching the surface. So, and I said today that there's going to be a deep dive. I think the saturation is happening because of the deep dive now. So I perfectly understand.
More interactive session.
Okay.
More interactive session and give us the chance to
To practice what? Okay. Okay. So since we have the slides already anyway, his session is meant to end this evening, but with this request now, that means we still have to give him a slot tomorrow for the practical, because this is very critical for persons that do deployment anyway. So maybe he has other things to tell us before so that we don't just close it suddenly like that. But we are doing advanced high performance computing. So let's put that in mind. So thank you. Okay, yeah.
Okay. Okay, what to say? So let's continue tomorrow morning. So at least tomorrow morning we start with the practicals. So, but one thing you can do for me is to read the slides. Just read the slides. And if you don't understand something, Google it. Google it, try to read it. Then if you still don't understand tomorrow, bring your questions. Maybe the first 20 minutes or 15 minutes we used to answer questions. We used to answer questions. So something you do for me, read the slides. The first practical we did, try to complete it. Try to complete it. Then, even if it's possible, you have full chest, do the second practical. It's possible. It's not so hard. Docker is very simple. And you need this Docker for Kubernetes, because Kubernetes is much more complex than this, and it's really for deployment. Kubernetes is for deployment of applications. So try it out if you can do it on your own. And also, I put a slide there, the resources that I used to prepare this course. There are some YouTube videos there that I watched that was very, very helpful. There are some courses there. There are some documentations there. But you can just watch the YouTube videos too. It will help you understand. Docker is very interesting and it's simple. So just try it out. Read the slides. Spend a couple of minutes to watch the videos. Some of them are long. Some of them are 3 hours long. So I don't expect you to finish watching the videos. But just watch the introduction, watch some parts, read the slides to where we stopped. Try to practice the practicals. This practical we're about to do too, try to do it too. So when we come together, you'll just be asking me questions. So that we don't take too much time to tomorrow morning and we're able to finish everything tomorrow. So Docker is very interesting and simple. Kubernetes is a little bit harder than this, but it's all good. So I think we're okay. We can stop now. Thank you.